Hello everyone, today we'll talk about the solution to the problem find the closest palindrome. The statement is simple, you have to find the closest palindromic number to the given number, and if there are ties we have to return the smaller one. However, of course, a problem like this is rife with edge cases, and implementation thus is not that easy, but what can you do? Sometimes problems are annoying. So, the basic idea when it comes to solving this problem is that if we have some number, A, B, C, D, E, and so on, those are the digits of the number, then we can create a palindrome that's pretty close to this number. We know that for a palindrome the first half has to be the same as the second half reversed, so we can just take the first half and append to it the first part reverse. We have to remember that when it comes to odd length numbers, this middle element only appears once, and this is one candidate for a palindrome that's pretty close to the original number. And of course, to get a smaller palindrome, we can decrease this least significant digit of the first half by 1. To get a bigger number, we have to increase it by 1. So those are three natural candidates. Take the first half, maybe the first half plus 1, minus 1, append to it the same part reversed. Of course, when it comes to A, B, C, D, even length, then we would get AB, BA. And the same thing with B, increased by 1 and decreased by 1. We don't have to really worry about whether or not the number that we generate is a palindrome. We can just filter non-palindromes at some point along the way. Just make sure that all the candidates we get are palindromes. In general, the easiest approach is typically to generate all the candidates you can think of to cover all the edge cases, filter out the candidates that are incorrect, and then get the candidate that minimizes the score. So this is the basic idea. And of course there might be some situations where the closest palindrome is not of the same length as our number. That's, for instance, if our number is very big. For instance, it's just all 9s, or maybe the number is very small for its length, so it's just 1 and all zeros. But then the options are either all 9s of the same length, or all 9s of length 1 smaller, or the same thing but with some number of zeros and then 1, and that number of zeros can be such that the number is either of the same length or of length 1 bigger than the starting number. So for instance, if we have 999, then this is a palindrome that has distance 2 and of course its length 1 bigger. And if we have 100, we can get 101. The answer should be 99, that's because we have to return the smaller one, and they are both of the same distance. So there are 4 special candidates we can look at, and the candidates created by the first left part of the number, and that left part plus 1 and minus 1. There's also here an if statement if our number only consists of a single digit. I'm not sure if it's necessary for the logic, but here we use the length of the number minus 2. So to make sure that the number is not a single digit, the easiest way is just to have an if here and not an if here, which will interfere more with the logic of the problem. And of course, those first basic options are generated by taking the number plus the number reversed. And that number is either the whole first part, that's in terms of even length palindromes, or the whole first part minus the last element. So we just subtract the n modulo 2. So that's the same thing as n bitwise ended with a 1. That's the least significant bit of the number n, where n is of course the length of the number that we're given. And at the end, when we have those 3 options and those 4 special options here, we only keep those that are a palindrome and that are not equal to the starting number, because we cannot return the starting number, not including itself, it says in the statement. And after that filtering, we have to return the one that minimizes the distance. If there are ties, we have to return the smallest one. So we can just return the minimum over pairs of score and value, and the value that generates that score. And the score is, of course, this is the difference, the absolute difference between the number and the option. And we want to favorize smaller options, so we can just multiply this thing by 2 and subtract 1 if the number is greater than the option. which means that options that are smaller than the number will have slightly smaller score, and of course we want to minimize the score, so we favor smaller options. And at the end we just return the option that generated it, because the zip zips the scores of options, which is this map, with the options. So pretty annoying problem. I think all the edge cases are covered here. It certainly passes the tests, but the general idea is something like this. And it's often useful in difficult problems to have this approach. Just generate all the options, throw out the options that you know are incorrect, and then take the best option. Instead of thinking about, okay, when is this option the best, when is this option the best, just generate all of them and try all of them.